Somewhere over occupied Europe, in the freezing winter of 1943, a German Luftwaffe pilot watched something strange through the fogged-up glass of his cockpit. It was an American fighter, yes, but not one of those chubby thunderbolts he was used to seeing. This one was different. Too sleek, too beautiful, almost fragile in its streamlined appearance. He smiled behind his oxygen mask. Another easy target, he thought. Another victory to add to his already impressive tally. But then something happened. Something he would never forget. That silver fighter simply sped off, leaving him behind as if his Messerschmitt were a toy dangling from a string. And in that moment, everything changed. The air war over Europe would never be the same again. This is the story of how an aircraft that was initially ridiculed, despised, and nearly cancelled before it could even prove its worth, became the most lethal weapon in the Allied arsenal in the skies of Europe. This is the story of the P-51 Mustang, an aircraft so advanced in engineering, so counterintuitive, and so brilliantly executed that it defied everything the experts thought they knew about fighter design. And to understand why the Luftwaffe initially derided it, to understand why even the Americans themselves doubted it, we need to go back in time and understand how it all began. But before we dive into this incredible story, if you enjoy fascinating stories about engineering, aviation, and the moments that changed history, subscribe to the channel now, and leave a comment with the time you're watching this. Let's go. It was April 1940. Europe was in flames. France was about to fall. Britain was fighting desperately for its survival. And across the Atlantic, in the United States, a small aircraft company called North American Aviation was receiving an order that would change the course of history. The British were desperate for fighters. Their Spitfires and Hurricanes were being destroyed faster than they could be produced. They needed planes, lots of planes, and they needed them fast. The British Purchasing Commission approached North American Aviation with a simple proposition: build the P-40 Warhawk under license for us. But James Kindleberger, the president of North American Aviation, was a man of vision. He looked at the P-40, a fighter that was already becoming obsolete before it even entered mass production, and said something that must have sounded like absolute madness at the time. He said, "No, we're not going to build you the P-40. We're going to build something better. We're going to build a completely new fighter, from scratch. And we're going to do it in 120 days. 120 days. 4 months. To design, develop, and build a prototype of an entirely new military fighter." To put that in perspective, most aircraft development programs at the time took years, not months. The British must have thought Kindleberger was crazy, but they were also desperate. So they made a deal. If North American Aviation could truly deliver a superior fighter in 120 days, they would buy it. And so began one of the most ambitious and improbable engineering projects of World War II. Edgar Schmude, the German chief engineer who had emigrated to the United States, assembled his team. They had no time for extensive experimentation, no time for prolonged testing. They needed to get it right the first time, or nearly so. And what they created was absolutely revolutionary. Let's talk about the wing, because this is where the Mustang's story really gets fascinating. Schmude and his team chose a wing profile called the NACA 45-100, a laminar section that was at the time largely untested in combat applications. Most fighters of the era used thicker wings with conventional profiles that were proven and predictable. But Schmude wanted something different. He wanted a wing that would keep the smooth laminar airflow close to the surface for as long as possible before becoming turbulent. Why? Because drag is the enemy of speed, and speed would be the difference between life and death in the sky. But here's the problem. Laminar wings are incredibly difficult to manufacture correctly. Any imperfection, any misplaced rivet, any small ripple in the surface and the laminar flow breaks down. You lose all the aerodynamic advantages and end up with a wing that's worse than conventional ones. It was a huge risk, a risk that could have doomed the entire project. But Schmude had a trick up his sleeve. He designed the wing to be built to absurdly tight tolerances. Every panel had to be perfect. Every joint had to be smooth. Rivets had to be flush-fitted and polished. It was precision manufacturing on a scale never before attempted in mass production, and it worked. When the first prototype was tested, engineers were shocked. Drag was significantly lower than any contemporary fighter. The Mustang simply sliced through the air in a way other planes couldn't. But there was a problem. A big problem: the engine. The British had specified that the plane should use the Allison V1710 engine, the same engine used in the P-40. It was a decent engine at sea level, but its performance plummeted at high altitudes because it lacked a high-altitude supercharger. And here's the cruel irony. North American aviation had created an absolutely brilliant airframe, a masterpiece of aerodynamic design, but was stuck with an engine that simply couldn't tap into its full potential. The first Mustangs, called Mustang MKI by the British, entered service in 1942, and they excelled at low and medium altitudes. Fast, agile, with excellent cockpit visibility, thanks to the revolutionary bubble canopy design. But above 5,000 meters, they were slow, heavy, vulnerable. The Luftwaffe quickly realized this. All German pilots had to do was climb, gain altitude, and suddenly that beautiful, elegant fighter became a sitting duck. That's why the Luftwaffe mocked it. Not because the design was bad, but because the engine couldn't power that brilliant design at the altitudes where dogfights really took place. The Americans watched with frustration. They saw the potential. They understood they had something special on their hands. But a fighter that only performs well at low altitudes has limited use in a war where high-altitude airspace control is crucial. Some wanted to cancel the program. Others wanted to relegate it to reconnaissance and ground attack missions. The P-51 Mustang, for all its brilliant engineering, seemed destined to be a footnote in aviation history. And then something extraordinary happened. Something that can only be described as one of the most perfect marriages of airframe and engine in the entire history of aviation. In England, Rolls-Royce was producing an engine called the Merlin, the same engine that powered the legendary Spitfires. It was a magnificent engine with a two-stage supercharger that maintained its power even at extreme altitudes. Someone, and there's debate over who exactly came up with the idea first, suggested the unthinkable. What if we put the Merlin in the Mustang? It was a crazy idea for several reasons. First, the Merlin was a British engine, and putting it in an American aircraft would create logistical nightmares. Second, the Merlin was significantly different from the Allison in terms of dimensions and assembly. Adapting the Mustang's airframe to accept it would require a substantial redesign. Third, no one knew if the combination would actually work. It could be a complete disaster, but someone in the RAF had the vision to try. A Mustang was shipped to Rolls-Royce in Hucknall, where engineers began integration work. It was 1942, and little did the world know it was about to witness the birth of the most dominant fighter of World War II. The first flight tests were conducted in October of that year, and what happened next was nothing short of magical. The test pilot climbed in, opened the throttle, and suddenly that brilliant airframe had the engine it always deserved. Top speed jumped from 460 kilometers per hour to over 700. The rate of climb improved dramatically. The service ceiling soared into the stratosphere. Suddenly, the Mustang wasn't just competitive at high altitude, it was superior. The Americans paid attention. Packard Motor Company was already producing the Merlin under license in the United States, so the logistical nightmares could be managed. North American aviation received the go-ahead. The P-51B was born, the first mass-produced Merlin-powered Mustang. And when these planes began arriving at combat units in Europe in late 1943, everything changed. Absolutely everything. But before we get to the epic battles that were to come, we need to understand exactly what made the P-51's engineering so special, so ahead of its time. Let's talk about the radiator. Yes, the radiator. Because even something as mundane as the engine cooling system was transformed into a performance advantage in the Mustang. Most fighters of the era had radiators mounted in the front or in pods under the wings, creating significant drag. Schmood had a different idea. He placed the radiator under the rear fuselage in a specially designed duct. But here's the genius. The duct wasn't just a passive tunnel. It was a Meredith duct, named after the engineer who developed the concept. As air flowed through the radiator, it was heated. Hot air expands, and if you design the duct correctly, with the right shape, that hot expanded air is expelled rearward at greater speed than it entered, creating thrust. Thrust! The Mustang's cooling system not only created no net drag, it actually contributed to the plane's thrust. It was engineering of the highest order. Then there was the fuselage. Schmood and his team used the rule of areas. an aerodynamic principle that was just beginning to be understood at the time. Simply put, if you keep the total cross-sectional area of the aircraft fairly constant along its length, you minimize wave drag at speeds near sound. The Mustang had an incredibly clean and streamlined fuselage, with smooth curves and carefully shaped transitions. Nothing was there by accident. Every line, every curve had an aerodynamic purpose. And then there was the cockpit. Ah, that marvelous cockpit. Previous fighters had canopies framed with multiple glass panels, creating blind spots and a structure that blocked vision. Schmid introduced a bubble canopy, especially on later versions of the P-51D, which gave the pilot 360 degrees of visibility. A pilot could see behind, to the sides, up and down. In aerial combat, where situational awareness is everything, where he who sees first usually wins, this was an invaluable advantage. The armament also evolved. Early versions had wing-mounted 30-caliber machine guns, but these were soon replaced by 6, and then 4 50-caliber Browning machine guns. 450s were more than enough to destroy any enemy fighter, and the reduction to 4 guns saved weight and space for more ammunition and, crucially, more fuel. Because fuel, more than any other unique feature, would be what made the P-51 truly revolutionary. But we're getting ahead of ourselves. Let's go back to late 1943, when the first Merlin-powered P-51Bs began operating over Europe. Luftwaffe pilots soon realized something had changed. Those Mustangs they had learned to avoid simply by climbing were no longer so easy to avoid. These new Mustangs could climb with them. They could race with them. They could outrun anything Germany had in the air. The Focke-Wulf 190, previously dominant, suddenly met its match. The Messerschmitt 109, then a war veteran being constantly improved and modified, was now at a disadvantage. And there was something else. Something no one had fully anticipated. These Mustangs could fly further, much further. The P-51, thanks to its exceptional aerodynamic efficiency and generous internal fuel tanks, already had impressive range. But engineers added drop-in fuel tanks under the wings. Suddenly the Mustang could fly from bases in England to Berlin and back. No Allied fighter had ever achieved that before. American heavy bombers, the Flying Fortresses and Liberators, had been flying strategic bombing missions over Germany since 1942, but they were suffering terrible losses. Their escort fighters, primarily P-47 Thunderbolts, could carry them so far, but then they had to turn back, leaving the bombers vulnerable over the target and on the way back. The Germans learned to time their attacks, waiting until the escorts had turned for home, before launching waves of fighters against the bomber formations. The losses were unsustainable. There were serious discussions about whether daylight strategic bombing was even viable. And then the P-51 changed everything. Suddenly, bombers could have fighter escort throughout their missions, there and back. American fighter pilots no longer had to turn home, while their bomber comrades continued on. They could stay. They could fight. They could protect, and fight they did. Beginning in early 1944, Mustang squadrons began escorting bomber formations deep into German territory, and the Luftwaffe had to respond. They had no choice. They couldn't simply let the bombers destroy their factories, their refineries, their infrastructure. Then they scrambled. Dozens, then hundreds of German fighters swooped in to intercept the formations, and the Mustangs were waiting. Battle after battle, combat after combat, the Mustangs proved their superiority. It wasn't just that the plane was better, although it was. It was that the combination of superior performance, incredible range, and increasingly experienced and confident pilots created an irresistible winning formula. The Luftwaffe pilots, many of them veterans with years of combat experience, suddenly found themselves at a disadvantage. And here's something people often misunderstand about aerial warfare. It's not just about which plane is faster or more maneuverable. It's about tactics. It's about strategy. It's about being in the right place at the right time, with superior energy and positioning. The P-51 gave American pilots all these advantages. Its superior speed meant they could choose when to engage. Its improved climb rate meant they could gain altitude quickly. Its range meant they were always there, always present, always a threat. And its maneuverability, especially at high speed, was exceptional. The Mustang could dive, chase, turn, climb, and do it all better than almost any opponent. There was a saying among fighter pilots, "Speed is life." Altitude is life insurance. The P-51 gave American pilots both in abundance. But let's not romanticize it too much. Aerial combat was terrifying, deadly, and relentless. Pilots on both sides died every day. The skies over Europe in 1944 were some of the most dangerous places on Earth. But the numbers tell a clear story. As 1944 progressed, the Luftwaffe's losses steadily mounted, not just in aircraft but in pilots. Experienced pilots, trained pilots, pilots who couldn't be replaced quickly enough. Germany could still produce aircraft, though increasingly difficult as factories were bombed. But it couldn't produce experienced pilots. Training took time, and time was something Germany didn't have. Meanwhile, Mustang squadrons multiplied. More groups arrived from America. More pilots were trained, and every Mustang pilot knew he was flying the best fighter in the sky. That confidence mattered. It mattered greatly. In March 1944, one of the most audacious missions of the aerial war began. The first bomber escort to Berlin, the heart of Nazi Germany. A mission of over 1,000 miles round trip. Before the P-51, it would have been impossible, but now it was not only possible, but happening regularly. The Germans fought fiercely. Berlin was the capital of the Reich. Defending it was a matter of pride, propaganda, and morale. Dozens of German fighters scrambled, and they were met by dozens of Mustangs. The skies over Berlin in those days became a slaughterhouse. But at the end of each mission, when the bombers returned home, they returned under the silvery protection of their Mustang escorts. There were aces, of course, pilots on both sides who excelled, who became legends. But even the German aces, men with dozens, sometimes hundreds of victories, began to fall. Some were shot down in combat. Others simply stopped flying, their units out of fuel, out of spare parts, without hope. Allied air superiority over Europe was being established, and the P-51 Mustang was the tool that forged it. But let's return to engineering for a moment, because there's more to the story than just the airfoil and the engine. There were the small details, the small innovations that, when combined, made a huge difference. The Mustang's hydraulic system was elegantly simple, yet effective. It controlled the landing gear, flaps, and brakes, but it was designed to be reliable, to perform even under the most extreme conditions. The flight controls were balanced and harmonized, giving the pilot natural feedback and allowing precise maneuvers even at very high speeds. Many fighters of the era became heavy and unresponsive at high speeds, but the Mustang maintained its agility. The instrumentation was clear and well organized. Everything a pilot needed was at hand, visible at a glance. It may not seem like much, but in combat, when every second counts, when you're being fired upon, when adrenaline is pumping and the terror is real, having intuitive controls and clear instrumentation can mean the difference between life and death. And then there was reliability. The Merlin engine, though complex, was extremely reliable when properly maintained. And the Mustang's airframe proved robust and durable. Planes returned from missions with considerable battle damage and still landed safely. The airframe was strong enough to withstand the stresses of violent combat maneuvers, yet light enough to maintain performance. It was a delicate balance, and Schmood and his team nailed it perfectly. As 1944 progressed into 1945, the P-51's dominance over European skies became total. The Luftwaffe, once the world's most feared air force, was being systematically destroyed. Its bases were bombed, its supply lines were cut, its pilots were exhausted and outnumbered. In February 1945, the Luftwaffe attempted one last major effort, Operation Bodenplatte, a massive coordinated attack on Allied airfields in Western Europe. Hundreds of German fighters and fighter bombers attacked at dawn, attempting to destroy Allied aircraft on the ground. They had some initial success, destroying dozens of aircraft, but the response was swift and devastating. Mustangs took off from airfields that had not been hit. They intercepted the Germans as they returned home, low on fuel and lacking coordination. It was a massacre. The Luftwaffe lost over 300 aircraft that single day. Losses they could not replace. Pilots they could not replace. It was effectively the Luftwaffe's last gasp as an effective fighting force. In the final months of the war, Mustangs flew almost unopposed. They escorted bombers, of course, but they also conducted ground attack missions, strafing trains, trucks, and troop columns. They hunted any German aircraft that dared take off. They controlled the sky so completely that the Allies could operate with virtual impunity. And all of this domination, began with that brilliant airframe designed in 120 frantic days in 1940, combined with that magnificent British engine in 1942. But the Mustang story doesn't end in Europe. As the war in Europe drew to a close, the war in the Pacific continued. And there the P-51 would find a different, but no less important role. The B-29 superfortresses were bombing Japan from bases in the Mariana Islands. It was a long, difficult, and dangerous mission, and initially they flew without fighter escort. No fighter had the range to make the trip. None except the P-51. Modified with even larger fuel tanks, Mustangs began escorting the B-29s on their missions over Japan. These missions lasted 8, 9, sometimes 10 hours. Pilots sat in a narrow cockpit over the ocean, relying on precise navigation and hoping their engines would keep running. And they did. The Mustangs were there over Tokyo, Osaka, and Nagoya. There the Japanese fighters, already desperate and with few trained pilots, tried to intercept the bombers. And once again, the P-51 proved its superiority. The primary Japanese fighter in the final stages of the war was the Ki-84 Hayate, an excellent aircraft in its own right. But facing experienced American pilots in Mustangs, they stood little chance. The P-51's range, its most distinctive feature, meant fighter escorts were available over Japan in the summer of 1945, something unthinkable just a few years earlier. And by the time the war ended in August 1945, the P-51 Mustang had proven itself to be one of the most important aircraft, if not the most important of World War II. Its statistics are impressive. Over 15,000 were built. They shot down thousands of enemy aircraft. They escorted countless bombing missions. They helped establish air superiority over 2 theaters of war on different continents. But numbers don't tell the whole story. The P-51 represented something more. It represented brilliant engineering triumphing over convention. It represented the courage to try something new, even when it seemed impossible. It represented the perfect combination of design, engine, and purpose. Edgar Schmude, the German engineer who designed the plane, lived to see his creation change the course of the war. James Kindleberger, who staked his company's reputation on an impossible deadline, was vindicated 1,000-fold. And the pilots, those young men who flew the Mustang in combat, knew they were flying something special. There was a respect, almost a reverence for the plane. It took them to the enemy. It brought them home. It gave them the edge they needed to survive and win. After the war, the P-51 continued to serve. It flew in the Korean War, providing close air support. Some air forces around the world continued to operate it until the 1960s. And today, more than 80 years after its first flight, restored Mustangs still fly in air shows, a living testament to an era of total war and desperate innovation. When you see one, when you hear that unmistakable Merlin engine sound, when you see those clean, elegant lines, you're looking at a masterpiece of engineering. You're looking at an aircraft that changed warfare. You're looking at the P-51 Mustang. But let's return to that moment that began our story. That German pilot over-occupied Europe in the winter of 1943, seeing a Mustang for the first time and thinking it would be easy prey. He learned that day that the world had changed, that Germany no longer had the best of everything, that the sky was no longer theirs, and that lesson was learned by hundreds, then thousands of Luftwaffe pilots in the months that followed. Some survived to tell the tale. Many did not. And at the center of it all was that sleek silver plane, the product of 120 days of frantic work and years of visionary thinking. The P-51 Mustang's engineering was insane because it defied convention. It was insane because it attempted things experts said were impossible. It was insane because it took risks that could have failed spectacularly. But it didn't fail. It triumphed. And in triumphing, it proved that bold engineering, clear vision, and relentless execution can change the world. The Luftwaffe mocked it at first because they saw a plane with a bad engine, but they didn't see the potential. They didn't see what was coming, and by the time the right engine met the right airframe, by the time it all came together, it was too late. Air superiority was lost. The war was lost. And the P-51 Mustang, that fighter that almost wasn't, had become immortal. Today, when aeronautical engineers study aircraft design, They still look to the P-51. They still study that laminar wing profile. They still admire that clean, streamlined fuselage. They still appreciate that ingenious Meredith duct, because the Mustang wasn't just a great airplane for its time. It was an airplane that established principles and demonstrated possibilities that still resonate today. The pursuit of aerodynamic efficiency, the importance of integrating all of an aircraft's systems into a harmonious whole, the value of taking calculated risks in design. All these lessons came from the P-51, and there's something else, something about the very shape of the plane, that timeless elegance. It's beautiful not just because it's efficient, though it is. It's beautiful because form follows function so purely that the result is almost art. There are no wasted lines. There are no unnecessary features. Everything is there for a reason. And when it all works together, when that Merlin engine roars to life and that propeller begins to spin and that plane soars into the sky, there's a grace in it that transcends engineering. It's poetry written in aluminum and jet fuel. It's beauty born of necessity. It's perfection achieved through commitment to purpose. The men who designed the P-51 weren't perfect. They made mistakes. The first engine was the wrong choice. Some design decisions had to be revised. But they persevered. They learned. They improved. And in the end, they created something that lasted far beyond their lifetimes. Edgar Schmood lived until 1985. He saw the legacy of his work endure for decades. He saw the Mustang become an icon. And in interviews in his final years, he spoke of the P-51 with pride, but also with modesty. He knew he hadn't done it alone. He knew he had been part of a team, part of a larger effort. But he also knew he had created something special. And here's the thing about great engineering achievements. They rarely come from individuals working alone. They come from teams, from collaboration, from people with different skills and perspectives working together toward a common goal. The P-51 was the product of American aeronautical engineers, building on British insights using a British engine, incorporating aerodynamic principles that had been developed over decades by researchers in multiple countries. It was a truly international effort, even in the midst of a global war. And perhaps there's a lesson in that even in the worst circumstances, human cooperation can produce remarkable things. But let's talk about the pilots one more time, because ultimately, the P-51 was a tool, and tools are only as good as the people who use them. The pilots who flew the Mustang in combat were mostly very young men, in their early 20s. Some were still teenagers. They came from farms in Iowa, cities in California, small towns in Texas. Many had never seen an airplane up close before enlisting. And then, after months of intensive training, they found themselves flying one of the most sophisticated machines ever created, in mortal combat against pilots who had been at war for years. The fear they must have felt is unimaginable. But they flew anyway. Mission after mission, day after day, there were rituals. Before each mission, a briefing. Maps were studied. Routes were planned. Targets were designated. Radio signals were reviewed. And then the walk to the plane. That moment of solitude before climbing into the cockpit. Each pilot knew they might not return. The statistics were brutal. But they climbed anyway. They strapped in. They checked their instruments. They started the engine. And when the formation took off, when dozens of Mustangs rose into the British sky and turned east, toward occupied Europe, toward Germany, they knew that in the coming hours, they would be tested in ways most people never experience. Air combat isn't like in the movies. It's chaotic. It's confusing. It happens at speeds the human brain can barely process. 1 second you're in formation, flying a routine escort. The next there are screams on the radio, tracers passing over your wing, a Messerschmitt diving out of the clouds. You brake right, pulling so hard that your vision begins to darken at the edges as the G-forces suck the blood from your head. You turn, search, find a target. Your hands move instinctively, training taking over where conscious thought would be too slow. The pipper on your visor aligns. You squeeze the trigger. The 450 calibers roar, the entire plane vibrating with the recoil. Tracers arc across the sky, and then you're passing, diving, losing contact, scanning for threats, checking fuel, trying to orient yourself, trying not to die. And the Mustang responded. In all these impossible situations, it responded. When you needed speed, it accelerated. When you needed to turn, it turned. When you took fire, it held. Pilots developed a bond with their planes. They gave them names. They painted nose art on them. They treated them with a mixture of affection and respect, because these planes were their lifelines. And they were wonderful. After a mission, when you returned home, when you saw the English coast appear on the horizon, and knew you had survived another day, there was gratitude. Gratitude for luck, of course, for skill, for training, but also gratitude for the plane, for that reliable machine that had done everything you had asked of it and more. Of course, not everyone returned. Empty chairs in the mess hall, empty bunks in the barracks. It was the reality of aerial warfare. Some were shot down in combat. Others suffered mechanical failures. Some were lost running out of fuel over the English Channel or the North Sea and never seen again. Others were hit by anti-aircraft fire, those deadly black explosions that filled the sky over defended targets. The Luftwaffe may have been outclassed in the air, but the German anti-aircraft gunners were excellent, and their weapons were lethal. A single misplaced fragment of shrapnel could bring down even the best flying Mustang. But for those who survived, for those who completed their combat tours and returned home, the P-51 remained a defining memory of their lives. Decades later, elderly veterans would speak of flying the Mustang with a distant look and a half smile. They would remember the sound of the engine, the smell of jet fuel and hot oil, the feel of the controls beneath their hands, the fear and the ecstasy and the sheer vital intensity of it all. And many would say the same thing. It was the best airplane they ever flew. Nothing else came close. The P-51 Mustang was special, and they had been privileged to fly it when it mattered, when everything was at stake, when the fate of the world hung in the balance. There's a story that sums up perhaps better than any statistic what the P-51 meant to the air war over Europe. It was the summer of 1944, a few months after D-Day. A large formation of bombers was attacking targets in Germany, Mustang escorts surrounding them as always. A young bomber pilot, flying his first mission, looked out the cockpit window of his B-17 and saw a P-51 flying in formation with them, so close he could see the fighter pilot staring back. And on the nose of that Mustang was painted a flying shark, white teeth against silver metal, fierce and protective at the same time. And the bomber pilot, this frightened young man on his first combat mission, felt a wave of relief, because he knew that as long as those Mustangs were there, he had a chance. A good chance. And he was right. His mission was successful. He returned home, and he flew another 24 missions, and those Mustangs were always there. Years later, he sought out that particular fighter pilot, the one with the flying shark on the nose of his plane. They met at a veterans reunion. They shook hands. They shared stories. And the bomber pilot said, "You saved my life that day. You and your Mustang. You brought me home." And the fighter pilot, older now, graying, but still with that calm, confident demeanor of fighter pilots, smiled and said, "It was just my job." But they both knew it was more than that. It was duty. It was honor. It was brotherhood forged in the fiery skies over Europe. And the P-51 was the instrument through which it all manifested. Now, it's important to recognize that the P-51, brilliant as it was, didn't win the war single-handedly. Of course not. Wars are won by men and women, by strategy and logistics, by industry and economics, by courage and sacrifice in 1,000 different ways. The P-51 was a piece, albeit a crucial one, of a much larger puzzle. But it was a piece that made a measurable and significant difference. Without the P-51, daylight strategic bombing over Germany would have been much more difficult, perhaps impossible at the scales undertaken. Without the P-51, air superiority over Europe would have been much more difficult to establish. Without the P-51, more bombers would have been lost. More crews would have died. The war could have lasted longer. So yes, the P-51 mattered. It mattered enormously. And the engineering behind it. That insane engineering that combined untested airfoils with impossible manufacturing tolerances, that marriage of the right engine with the right airframe, that relentless focus on every detail, all of it mattered. Because the war was won by margins, small advantages that compounded into great victories. And the P-51 gave the Allies an advantage the Germans simply couldn't match. They tried. They developed new fighters, the Ta-152, the jet-powered Me-262, but it was too late. They had no fuel. They had no pilots. They had no time. The P-51 and its cousins in the Allied arsenal had broken the Luftwaffe's back. And once broken, it could not be repaired. There's something deeply human about the story of the P-51. It's a story about ordinary people doing extraordinary things. The engineers who designed it weren't mythical geniuses. They were intelligent, hard-working men and women who faced an impossible problem and refused to accept that it was impossible. The factory workers who built it were ordinary workers, working overtime, driving rivets and welding frames and assembling engines day after day, knowing their work mattered. The pilots who flew it were ordinary young people from ordinary towns who found themselves in extraordinary circumstances and rose to them. And together, they created something that lasted, something that mattered, something that changed history. When we think about engineering, we often think in abstract terms, numbers, specifications, performance. But real engineering, the kind that matters, is about solving human problems. And in the case of the P-51, the problem was immense. How to win a war against a determined and skilled enemy. How to protect the men sent to bomb-defended targets. How to establish air control over thousands of square miles of hostile territory. These weren't academic questions. They were matters of life and death, and the answer in part was the P-51 Mustang. Decades after the war, as jet aviation became dominant, as the very concept of aerial warfare changed, the P-51 slowly withdrew from active service. But it was never forgotten. Aviation enthusiasts revere it. Historians study its impact. Engineers still learn from its design. And those restored Mustangs flying at air shows today are more than just vintage aircraft. They are monuments. They are reminders of an era when everything was at stake, when freedom and tyranny fought, and when ordinary people did uncommon things. And at the center of that struggle, soaring in the blue sky, was that sleek silver fighter, the product of 120 frenetic days and brilliant vision, the P-51 Mustang. So when we ask why the P-51's engineering was so insane, the answer is multifaceted. It was insane because it tried things that had never been done before. It was insane because it gambled everything on untested concepts. It was insane because it demanded perfection in manufacturing on an industrial scale. It was insane because it married a British engine to an American airframe and expected it to work perfectly. And it did. It was insane because it defied convention at every step. And why did the Luftwaffe mock it until it dominated the European front? Because they only saw what was on the surface. They saw a beautiful fighter with a bad engine. They didn't see the potential. They didn't see what was coming. And when they did, when those Merlin-powered Mustangs started appearing on their radars, started chasing them across the sky, started escorting bombers into the heart of Germany and back, it was too late. The story of the P-51 teaches us many things. It teaches us the importance of vision. James Kindleberger saw what others didn't when he said he would build a better plane in 4 months. It teaches us the importance of execution. Edgar Schmood and his team didn't just dream big, they delivered. It teaches us the importance of adaptability. When it became clear that the Allison engine wasn't suitable, they switched to the Merlin. It teaches us the importance of perseverance. When the first Mustang was ridiculed, they didn't give up. They improved. And it teaches us that great achievements rarely come easily. They come through hard work, calculated risks, and the willingness to try even when success isn't guaranteed. And perhaps most of all, the story of the P-51 teaches us that the tools we create shape the results we achieve. The P-51 wasn't just a product of its time. It shaped its time. It changed what was possible in aerial warfare. It changed how battles were fought. It changed the course of entire campaigns, and in doing so, it helped change the world. Not many engineering artifacts can claim that. Not many machines leave such a profound mark on history, but the P-51 Mustang did, and for that reason, it remains, even 80 years later, one of the most important aircraft ever built. When we look back now with the benefit of hindsight, it's easy to see the P-51 as inevitable. Easy to forget that there was nothing inevitable about it. It could have been cancelled. It could have failed. It could have been just another project that didn't work out. But it wasn't. And the reason it wasn't is because people made choices. They chose to attempt the impossible. They chose to take risks. They chose to believe they could do better. And they did. This is the essence of engineering at its best. It's not just about math and physics, although those things are important. It's about vision and courage. It's about seeing a problem and refusing to accept that it can't be solved. It's about making difficult choices and living with the consequences. And in the case of the P-51, the consequences were profound and lasting. There's a scene I sometimes picture. It's late afternoon in the summer of 1945. The war is over. Silence has fallen over fields that once echoed with the roar of Merlin engines. Somewhere in England, at a soon-to-be decommissioned American airbase, a mechanic is giving a P-51 its final checks. He knows this particular plane. He's cared for it for months. He's repaired it after combat missions. He's seen it take off with battle damage and return, against all odds. And now the war is over. And this plane, this magnificent piece of engineering, will soon be retired, dismantled, perhaps melted down. The mechanic runs his hand over the smooth metal of the fuselage. And for a moment, just a moment, he allows himself to feel pride. Pride in what this plane represented. Pride in the role he, a mechanic, played in keeping it flying. Pride in what they accomplished together. And all over the world, in thousands of different places, there are similar moments. Pilots putting away their flight helmets for the last time. Engineers filing away technical drawings. Factory workers shutting down production lines. All of them part of the P-51 story. All of them contributing to something bigger than themselves. And though not everyone knew it at the time, though many simply moved on with their lives, returned home, started families, found new careers, what they did would matter. It would matter to history. It would matter to future generations who would study their work, admire their accomplishments, and learn from their example. The P-51 Mustang's engineering was insane in the best possible sense. It was ambitious beyond reason. It was innovative beyond the norm. It was successful beyond expectation, and it was necessary beyond measure. The world needed the P-51 at that moment in history, and the P-51 was there. Ready, capable, dominant. It flew when flying meant everything. It fought when fighting was crucial. It won when winning was necessary. And for that, it has earned its place not only in the history books, but in the hearts and minds of all who understand what great engineering can achieve when combined with necessity, purpose, and human courage. The P-51's legacy continues. Every time an aeronautical engineer designs a wing, they think about efficiency, laminar flow, and minimizing drag. Lessons from the Mustang. Every time an aircraft is designed for maximum range, engineers study how the P-51 did it. Every time someone marries an airframe with an engine, they hope to achieve that magical synergy the Mustang found with the Merlin. The P-51 set standards. It set precedents. It established possibilities. And although technology has advanced immensely since then, although we now fly much faster, much higher, much farther, the fundamental principles remain. Good engineering is timeless. And so we come to the end of this story, but it's not really an end. Because the story of the P-51 Mustang continues. Every time someone looks up and sees one fly at an airshow. It continues every time an engineering student studies its design in a classroom. It continues every time a veteran shares his memories with an amazed grandchild. It continues every time someone reads about World War II and finds that sleek silver fighter in the pages of history. The P-51 isn't just history. It's inspiration. It's a reminder of what we can achieve when we challenge ourselves, when we refuse to accept limitations, when we dare to attempt what others say is impossible. So here's to the P-51 Mustang, to the engineers who dreamed it, to the workers who built it, to the mechanics who kept it flying, to the pilots who took it into battle, and to all the people, known and unknown, who contributed to its creation and its success. You did something extraordinary. You changed the world. And though many of you are gone, your work lives on. Silver, sleek, fast, lethal, immortal. The P-51 Mustang. The insane engineering that dominated the skies and helped win a war. And so ends the story of one of the greatest fighters ever built. A story of brilliant engineering, perfect timing, and extraordinary courage. The P-51 Mustang proved that sometimes, just sometimes, everything comes together exactly right. The right airframe, the right engine, the right pilots, at the right moment in history. And when that happens, when the stars align in this way, the result can change the world. If you enjoyed this epic story of the P-51 Mustang, Subscribe to the channel for more fascinating engineering and aviation stories, and leave a comment with the time you're watching this. Until next time, keep your eyes on the sky and remember, great things are possible when we dare to attempt the impossible.